where most of the students remain confused. A spring connected with two blocks. Mass is m1, mass is m2. Spring constant is k. Spring is assumed to be massless. Spring is assumed to be massless, you all know. So it is given a velocity u1 and u2. Either it can be in the same direction or opposite direction, doesn't matter. So the subsequent motion, I'll tell you, suppose what you call at t equal to 0, this is the situation given. Then you know what will happen. The overall system has a momentum towards right. mu1, mu2 both are in this direction. So as a whole, the two blocks plus the system taken plus the spring taken as the system, it has a momentum. So it will keep moving in the absence of horizontal forces, because horizontal forces are absent there. If you draw the free body diagram, you have weights and normal reactions. There are no horizontal forces. Remember, the two blocks plus the spring I have taken as the system. Spring may be exerting a force on the block. Block may be exerting a force on the spring, but they are all internal forces. We are talking of only external forces. So in the absence of external forces, the momentum of the system remains conserved. So it will go on moving towards right. But at the same time, it will oscillate also. Both the blocks will start oscillating. So the subsequent movement will be like this. Is it clear? The center of mass will keep moving to the right and it will oscillate also. Now the question is, what is the maximum extension or maximum compression? They may ask anything. Okay? So so let us find the maximum extension. Now there is no energy loss, you can see. There is no energy loss because collision is not taking place. So we can apply law of conservation of energy. We can always apply law of conservation of energy here. Now let us imagine that u2 is greater than u1. u2 is greater than u1. So after some time, let us say its velocity is more, so this will go more to the right and this will go less to the right. So the spring will expand. As spring expands, both the blocks will experience restoring forces. Restoring forces try to compress the spring. As soon as the spring expands, restoring forces will try to compress the spring. So for this block, the restoring force is like an accelerating force because it will increase the speed. Whereas for this block, the retarding, it's a kind of retarding force because it's going like this. Spring force is acting as a retarding force. So its speed will reduce, speed will increase. But still, as long as its speed is greater than its speed, there is a possibility of extension. The spring is getting extended. Finally, when both blocks attain same velocity, it is maximum. It is stretched to the maximum value when both blocks attain same velocity. Because thereafter, what will happen? You know, thereafter, this will slow down to a greater extent, and this will become fast. Then what? Then compression will take place. So at the instant of maximum extension, both blocks move together with a common velocity that you should understand. So you apply law of conservation of momentum then. You apply law of conservation of momentum. Here you have mass, it is extended to the maximum extent. And then you apply. So they will attain common velocity. So apply law of conservation of linear momentum in the horizontal direction. You have m1 u1 plus m2 u2. This is the initial momentum of the system. Initial means momentum here. Now at the instant of maximum compression, momentum will be how much? m1v plus m2v. You can take v common. So from here you have v. Okay? Sigma mu upon sigma m. Sigma mu upon sigma m. This is the common velocity acquired. Now you apply law of conservation of energy. Total energy remains same. Total energy remains same. So in energy initially is equal to energy finally. So initial energy is, for the blocks it is half m1 u1 square. For the other block it is half m2 u2 square. This is the kinetic energy. Spring had no elastic potential energy because the spring was in the relaxed state. This is the initial energy. Now final energy. The blocks are moving with common velocity. This. So you have to put this V square here, and the rest will be the elastic potential energy. And that elastic potential energy will be half kxm square. So from here you get xm. Xm is the maximum extension. Are you understanding? Okay. So from here you calculate xm and you get the answer. So let us do that. So half kxm square is equal to half m1 plus m2 into this thing, that is m1 u1 plus m2 u2 upon m1 plus m2 whole square minus this. So don't you think that it is a perfectly inelastic collision? Think of it. Don't you think? Both blocks are moving with constant same speed. Remember, perfectly inelastic collision, both bodies move with the same speed. So there is a standard expression of energy loss. Energy loss is half product of masses upon sum of masses into difference in velocity square. Loss in energy, loss in kinetic energy. I hope you know this. From here we find xm. From here, this is a standard expression. For a perfectly inelastic collision, this is the loss in energy. Okay? This is, I'm sorry, it is just the opposite. I want this, so it will be opposite of this, sorry. This is plus and this minus, I'm sorry. Okay? This minus this. So from here you get xm.